In this program, we're going to take a careful look at Orion. To my mind, the most magnificent constellation in the entire sky. He dominates the evening sky all through the winter months. There's so much to see there. The most famous object is probably the Great Nebula, a cloud of dust and gas where new stars are being born. This picture was taken with my own 15-inch telescope in my observatory. But Orion is full of wonders. My telescopes, of course, are in my garden. And Crispin Todd's now going outside to say more about Betelgeuse, Rigel, and the other stars that make up the cosmic hunter.
Betelgeuse is a marvellous name for a star. Not only does it trip off the tongue, but it has a wonderful translation. Armpit of the Great One. And it's there in the top left of the constellation. Its orange-red colour, which you can see with the naked eye, tells us that it's a giant. And in fact, Betelgeuse is so large that even from our position more than 400 light-years away, we can map its surface. It also forms a nice contrast with the star in the bottom right of the constellation, Rigel, the brightest star in Orion. Rigel isn't red, it's blue, and in fact it's a blue supergiant, burning through its fuel at a ridiculous rate. When it comes to the end of its life, Rigel, like Betelgeuse, will explode in a dramatic event known as a supernova, changing the face of its neighbourhood and of the constellation of Orion forever. The bottom left of the constellation is the much fainter Saiph, and then the top right is another giant, Bellatrix. And then we come to the most famous part of the pattern, the three belt stars. And running from right to left, we have Mintaka, Alnilam, and Alnitak, the three stars that make up Orion's belt. There's also the sword, which hangs down from the belt, and off to the side are the faint curve of stars that marks Orion's bow. With such a distinctive pattern of stars, it's no surprise that the constellation of Orion appears in mythologies from pretty much every culture.
Orion is so distinctive that there are obviously legends everywhere. And my favourite is the Greek one. Orion, the mighty hunter, boasted he could kill any creature on earth, but he forgot the scorpion, and the scorpion crawled out of a hole in the ground, stung Orion on the heel, and killed him. It seemed rather extreme, and the gods relented, and Orion was brought back to life and placed in the sky. But just to make things quite fair, the scorpion was brought back alive too, and also placed in the sky, but as far away from Orion as possible, so the two can never meet. And from here at least, Orion and Scorpius are never above the horizon at the same time. Lovely story. But of course, Paul, there are others.
There are indeed. The Babylonians, for example, of around the time of the Bronze Age, they saw the constellation as a shepherd, and they called him the Great Shepherd of Anu, and he was their chief god of the heavenly realms. But I think the people that made the most out of the constellation was, of course, the Egyptians. They were very keen on Orion, as we know. The pyramids of Giza all seem to be associated with the constellation, and the stars of Orion, for them, formed the god Osiris, who was, of course, the god of the afterlife and rebirth. So there were some very interesting early interpretations of the constellation.
Now, I think my favourite comes from the Aborigines.
Absolutely. The Yolngu people of Australia, they have a wonderful story. To them, the constellation represents a canoe. And there's a lovely story associated with this, and the idea is that there were two brothers out in a canoe fishing, and this particular river they were fishing on was populated by fish that was sacred to the people. And one of the brothers not only did spitefully catch a sacred fish, but he cooked it and ate it in the canoe as well. And the sun god was not impressed by this behaviour.
I'm not surprised.
He was very cross. And he sent a water spout, which placed them both in the heavens, canoe as well as the two brothers.
That's where we see them today.
That's where we see them today, and that's where they remain as punishment for catching the fish.
What about the Indians?
Well, quite. They didn't associate the constellation with the hunter at all. To them, it was called Mariga, and that is a type of deer. Another interesting one, of course, is the Chinese. They had some very interesting interpretations of all the constellations. Their maps were quite different to ours.
If they didn't use our constellations at all?
No, they didn't. In fact, you'll be familiar with the lunar mansions. Yes. So the idea was that as the moon went round the Earth, it stayed in a mansion, a different mansion each night, and one of the mansions was the constellation of Orion.
Even though they didn't call it Orion?
No, they didn't call it Orion at all. And in fact, various other parts of China didn't recognise that as a constellation and broke it up into various different forms. I just wondered, Patrick, when mankind goes out to the stars, what kind of constellations will he place in the skies of the worlds he sees out when he gets out there?
Do you go to Alpha Centauri? I think our sun's going to be in Gemini.
It's certainly fascinating to find out what people put in the skies in the future.
Constellations of the future, well, we must wait and see. Paul, thank you very much. Now back to Orion and the Hunter's sword hanging down from the belt. And there we find the misty patch, which we know to be the Great Orion Nebula, a cloud of dust and gas where new stars are being born. In fact, a stellar nursery. Over to Chris.
It was in 1774 that William Herschel described the nebula as an unformed, fiery mist, the chaotic material of future suns. And you know what? He was absolutely right, because the Orion Nebula is our nearest large star-forming region. The nebula is made of gas and dust. The gas is mostly hydrogen with a sprinkling of other elements, and the dust is rather like sand grains, but 10 times smaller. To see the dust properly, we have to look not in the visible, but in the infrared region of the spectrum, where the dust glows. And if you look at Orion in the infrared, you'll see clouds that extend to the edge of the constellation and beyond. Most of these clouds are in darkness, but we see the Orion Nebula itself because it's lit by massive stars that have recently formed within it. That's how this tiny patch of a much larger cloud came to be the jewel in Orion's crown.
There's certainly plenty to see in Orion. Pete and Paul are with my 15-inch telescope in my observatory.
Okay. My first view of the Orion Nebula was a 4.5-inch reflector. What was yours with?
Mine was with a 40mm refractor. So it's a bit of a contrast to this one.
Let's go back.
Okay, I think that's about right.
Is that it?
Yeah. Well, the Orion Nebula is really easy to find because it's right in the very centre of Orion's sword. So if you can locate the belt stars at the centre of Orion, they're quite easily to locate.
Yeah.
Three almost equal brightness stars in a line. The sword hangs down from that.
And one of the amazing things I find about the Orion Nebula is it is detectable, that little patch of mist, with the naked eye, and binoculars show it quite well as well.
They start to show that it's not a star in the centre, isn't it? It's actually a fuzziness around it.
But to see any real detail, of course, you do need a telescope. And I remember the first view of the Orion Nebula with my 4.5-inch reflector. And what I really thought was quite amazing was this big patch of nebulosity and this little cluster of stars, the trapezium, right at the centre.
That's right. I mean, the Orion Nebula, or to give it its catalogue name, it's known as M42.
Yes.
That's quite a familiar name for it.
That's how I know it, yeah.
It's, when you see it with a reasonable size, or even a small telescope, actually will show lots of detail. But you've got those really tightly packed stars in the centre of the nebulosity. They've actually been born out of the material which is in the nebula itself.
Yes, and they're blowing a hole into the nebula, aren't they?
They are,
So they're providing real
and they
structure
also
to it.
ionise a lot of the gas around the nebula, and that causes it to glow. Now, if you look at the nebula with a large telescope, can you actually see colour?
Now, this is an interesting thing. To my eyes, the Orion Nebula always looks fairly bluish.
Oh, right, okay.
Various shades of blue, but strongly bluish, but I think I'm sensitive to the blue end of the spectrum. But I'm told that a lot of people see it as green.
I see it as green, as a greenish smudge.
So I think that's probably the common colour. We should say that the beautiful deep reds and purples and hues that come out are entirely photographic.
That's
You're
right,
never
yeah,
going to see those.
But the nebula itself is really interesting. It's fascinating because it's got lots of different regions
Yes.
there. And on the other side of it, there's another nebula
That's right.
known as M43. Now, that looks a bit like a comma. It's fainter than the Orion Nebula,
is, yeah.
but it looks like a comma with a star in the centre of it. That star's NU Orionis, not to be confused with Nu Orionis. Rather confusing.
I have to say, a low-power eyepiece in a telescope like this, it shows the whole scene quite
It's
beautiful.
fantastic.
Now, we have a very interesting object, don't we? And that is the Running Man Nebula. I
It
believe.
is. Now, this is quite a tricky thing to see visually.
I have never seen, even with a telescope this size, a vague hint of nebulosity, that's about it.
But if you put a camera on that region, take a long exposure photograph, you see this bluish, purplish bluish cloud.
That's beautiful.
There are dark dust lanes across it, and they form the silhouette of a running man.
It looks more like a demon to me, but all right, Running Man it is.
The probably most distinctive feature of the Orion constellation is the belt, and there's lots of objects of interest around the belt. The three stars which make up the belt, the one on the left-hand side, as we look at it from the UK, or on the eastern side, is known as Alnitak. And if you just view slightly further off to the left, or east, there is a little patch of nebulosity there, which is known as the Flame Nebula.
Oh, the flame. Now, this is another one of those nebulae that doesn't seem to matter how much magnification or telescope you look at it, it still appears as a vague patch of mist.
It does, but it's photographs which bring out the beauty of it.
They do,
because this is quite a bright nebula, and it's difficult to see in the glare of Alnitak.
Yeah.
But there is actually dark nebulosity in front of it, which gives it the sort of, it looks a bit like a leaf to me sometimes.
It does, and of course, near to that, we have the very famous Horsehead Nebula.
The Horsehead is probably the most iconic dark nebula in the entire sky, isn't it?
It is.
Well, what's happening there is you've got a very large dark cloud of matter which obscures a lot of the background stars of that region. Now, there is a finger of dark dust material which is pushed out, and it pushes out so that it actually covers some of that bright curtain of nebulosity.
And that's what we're seeing as the Horsehead Nebula.
It's a silhouette of this dark finger which is there, and it looks a bit like a chess piece, a knight.
It does look just like a knight's chess piece. Quite remarkable.
We should say that the beautiful pictures you see of the Horsehead Nebulae are a little bit misleading, because to try and see it visually is very difficult.
It is. Even in a large telescope, you're still left with only a vague impression of a horse's head.
You need a really long exposure photograph.
Yes.
It's quite a nice target for astrophotography, actually. But if you look at it in slightly different wavelengths, say the near infrared, there's a beautiful picture which shows how the whole thing changes in appearance, because the bright curtain of nebulosity now appears dark.
That's right.
And the dark cloud, which appears dark in visual photographs,
is now very bright.
Well, you can see detail in it, so you can actually see this protuberance as an illuminated feature.
Well, Pete, all these wonderful objects are just waiting to be looked at.
The Dark Nebula really is amazing, but let's come back now to the Bright Nebula. And I've said that is a stellar nursery, and that's really true.
This is not just a place where stars are forming, this is a place where massive stars are forming. Not just stars like the Sun, but stars that are many times larger than the Sun. And that turns out to have a crucial effect. And of course we can see some of those massive stars.
Let's go on now to the famous trapezium cameo, because that's, I see that very well with my telescope.
Yes, the Trapezium Nebula, right in the heart of the Orion Nebula that we're seeing here, is a cluster of, it's a lots of very massive stars. The four that you see that are brightest make the shape of a trapezium, which is how it gets its name. Lots and lots of very massive, bright white, blue-white stars.
Interestingly, even Galileo saw it as a multiple star, and he noticed that there was something odd going on, but he didn't remark on this wonderful nebulosity. It's still very surprising to me that he commented on the double star or the triple star, or indeed the quadruple star, but not everything else that's going on.
Very odd. We see the trapezium because the stars are on our side of the nebula, but there, of course, there are massive stars inside that we can't see and never will.
Almost certainly. I think the other reason we see the trapezium is that those stars are relatively old by Orion standards. So they're still young compared to the Sun. The Sun is, what, 5 billion years old, or maybe a little less than that. The trapezium stars are just 30 million years old, and it's their light that lights up the rest of the nebula. The other thing that they've done is they may well be the source of star formation in this particular region. When you have a massive star like those in the trapezium forming, it undergoes a very turbulent process in its young life, and you quite often get jets shooting out from the star. We see other examples of this in Orion. Of course, if you have massive stars, they don't live for very long. They're the rock stars of the universe. They live fast. They die young. And if there have already been stars here that have exploded as supernovae, then that will have sent shockwaves out into the gas. And those shockwaves can trigger the process of star formation. And so a typical star in Orion is only a couple of million years old. But that may be because their formation waited to be triggered from the trapezium.
One thing we've got to bear in mind, in this picture, we see vivid colours. Look through a telescope and you won't see those colours.
Well, the colours here are actually representing different molecules often, and some a lot more complex than we might imagine. So as well as the hydrogen, there's other molecules that are formed within stars originally. There's lots of carbon and oxygen, so you've probably got a lot of carbon monoxide. There's lots of nitrogen. You have things like hydrogen cyanide, so it's not a very nice place to be. No. Lots of ammonia and so on. But they're also much more complex molecules. I mean, there's even alcohol in there as well.
Yeah, famously, you can find ethanol in the Orion Nebula, just as we do in all star formation regions, and these molecules tell us about what's going on.
By cosmic standards, the Orion Nebula is close to us.
Yeah, that's why we study it so intently, because it's the nearest place where these big stars are forming. It's about 1,500 light years away, something like that, and that is close. One of the advantages that gives us is we can look at the Orion Nebula as a laboratory that tells us about where most stars form. And if we zoom right in now and look at some of these forming stars, we see these marvellous features called propylids, yes, or protoplanetary disks. So you not only have a star forming within this little cocoon deep within the nebula, but you can actually see the dust that remains around the newly formed star, and we presume that this disk will go on to form planets, just as must have happened in our solar system 5 billion years ago.
You know, comparing to Orion, the one thing we don't find there are bright galaxies.
No, that's right, and to explain that we have to think about our own galaxy. And so I have here a reconstruction. This is an artist's impression of what the Milky Way looks like, based on a huge amount of work with the Spitzer Space Telescope.
It's a barred spiral.
It is. You can see the bar in the centre here. It's got two main arms, and then there's this curious feature here, which is almost like a stunted spiral arm, and we call this the Orion spur. The reason it has that name is that if you imagine the sun on this picture, we're about here. And when we're looking at Orion in the sky, what we're doing is we're looking down through this Orion spur. And when we look at Orion in the sky, we're looking into a spiral arm. And that's why we see all of this star formation. Star formation happens in spiral arms in a spiral galaxy like the Milky Way. We see all these beautiful star clusters, but it also blocks our view to the outside universe. If you think about the summer sky, when you look the other way, you're looking towards Scorpius and Sagittarius, the centre of our galaxy, and in the spring and the autumn, it so happens that we're looking out of the galaxy, either this way or into the screen here. And so in spring and autumn, we have a clear view of the rest of the universe. In the summer, and particularly in the winter, when we're looking towards Orion, we're looking through the disk of our own galaxy.
You know, there's one more point about Orion. It's a marvellous signpost in the sky. For example, take the stars of the belt. Downwards, they point to Sirius and the Great Dog, the brightest star in the sky. Upwards, they lead you first of all to Aldebaran and the Hyades, and then to the Pleiades. There are many other stars you can find by the Orion pattern.
If you want to know the sky, Orion's a great place to start.
So both, thank you very much. You know, there's plenty to see in Orion, and it guides you to the rest of the sky. Now, next month is our 700th Sky at Night programme, and we'll try to answer some of the questions you've sent in. And don't forget our website, bbc.co.uk/Sky at Night. And so, until next month and our 700th showing, good night.
To the left, we have Mintaka, Alnilam, and Alnitak, the three stars that make up Orion's belt. There's also the sword, which hangs down from the belt, and off to the side are the faint curve of stars that marks Orion's bow. With such a distinctive pattern of stars, it's no surprise that the constellation of Orion appears in mythologies from pretty much every culture.
Orion is so distinctive that there are obviously legends everywhere. And my favourite is the Greek one. Orion, the mighty hunter, boasted he could kill any creature on earth, but he forgot the scorpion. And the scorpion crawled out of a hole in the ground, stung a cloud of dust and gas where new stars are being born. This picture was taken with my own 15-inch telescope in my observatory. But Orion is full of wonders. My telescopes, of course, are in my garden. And Quislintott's now going outside to say more about Betelgeuse, Rigel, and the other stars that make up the cosmic hunter.
Betelgeuse is a marvellous name for a star. Not only does it trip off the tongue, but it has a wonderful translation. Armpit of the Great One. And it's there in the top left of the constellation. Its orange-red colour, which you can see with the naked eye, tells us that it's a giant. And in fact, Betelgeuse is so large that even from our position more than 400 light-years away, we can map its surface. It also forms a nice contrast with the star in the bottom right of the constellation, Rigel, the brightest star in Orion. Rigel isn't red, it's blue, and in fact it's a blue supergiant, burning through its fuel at a ridiculous rate. When it comes to the end of its life, Rigel, like Betelgeuse, will explode in a dramatic event known as a supernova, changing the face of its neighbourhood and of the constellation of Orion forever. The bottom left of the constellation is the much fainter Saiph, and then the top right is another giant, Bellatrix. And then we come to the most famous part of the pattern, the three belt stars, and running from right to
Orion at the heel and killed him. It seemed rather extreme, and the gods relented, and Orion was brought back to life and placed in the sky. But just to make things quite fair, the Scorpion was brought back alive too, and also placed in the sky, but as far away from Orion as possible, so the two can never meet. And from here at least, Orion and Scorpius are never above the horizon at the same time. Lovely story. But of course, Paul, there are others.
There are indeed. The Babylonians, for example, of around the time of the Bronze Age, they saw the constellation as a shepherd, and they called him the Great Shepherd of Anu, and he was their chief god of the heavenly realms. But
Good evening. For this program, we're going to take a careful look at Orion. To my mind, the most magnificent constellation in the entire sky. He dominates the evening sky all through the winter months. There's so much to see there. The most famous object is probably the Great Nebula,